Okay, yeah, every year NOAA has a conference down in Boulder where people show off their latest observational data, ozone measurements, temperature measurements, methane, stuff like that. And what I measure is volcanic dust in the atmosphere using lunar eclipses. So I gave a presentation. Again, I've been doing this about 10 years in a row. I would like to point out the picture up here in the corner, the super wolf moon eclipse taken by this fellow here. So I put a little eye candy on it, or clickbait, or whatever you want to call it. Because a pretty picture attracts people to the poster. So, there you go.
What's the graph?
Oh, okay, the graph is volcanic activity over the past 200 years.
Okay.
So what I've done is gotten lunar eclipse observations from articles, books, things, going back to the 1800s, and used those to determine how much volcanic dust was up there. And the big spike here is the infamous eruption of Tambora in Indonesia. And that's the one that is responsible, or supposedly, most people think so, but not all, for the quote, year without a summer, when there was July freezes in New England and northern Germany and places like that, crop failures. And, it was a bad summer for agriculture. And probably due to the volcanic dust basically blotting out the sunlight. And since then, the biggest one was Pinatubo back in 1991. It was in the Philippines.
Okay, I'm glad.
The scale go all the way to 0?
Huh?
I can't read the scale. Go all the way to 0?
Okay, 0 is here. That's negative,
That's the noise.
yeah, basically noise. And this up here is 0.3. Well, 0.3 what? It means the direct sunlight was reduced by 0.3 or 30%.
Wow.
That is a lot, yes. It's
Rich,
basically like an Arctic sun shining on the equator. That's 16, yeah. The eruption was 1815, the eclipse is 1816.
We missed that one.
And yeah, and another thing of interest is that since Pinatubo, there's been nothing. And it's actually the longest period of quiet volcanic activity, in the whole 200-year record.
So does that mean there's probably something big gonna happen soon?
Well, since they're kind of random,
Yeah,
it doesn't.
he keeps telling me he's not gonna predict.
that's good. How about Yellowstone? Yeah. how about-
Yeah, it's gonna be the Yellowstone volcano.
Well, Yellowstone will,
Yeah,
Rich, can you tell us who you are and why you're interested in all this, please?
oh, who am I? I
Uh,
live up on Gap Road, retired meteorologist, climatologist from University of Colorado. And this is of interest to me because it's fun. I like looking at lunar eclipses. And I like, especially since you can extract data, something of geophysical scientific interest from lunar eclipses. People sort of tend to ignore them and say, oh yeah, it's a red moon, okay, cute. But there's actually science you can do with lunar eclipses.
So how does, so how do you extract this information from lunar eclipses?
Okay. That could be like a,
yeah, that would
it'd
be.
be like
And
a
wait,
30.
We'll have
And
to talk,
explain it in
we have a whole talk on that.
Well, just
but
quick,
give her a
okay.
rough
Yes,
idea.
You've seen a lunar eclipse out there,
Yes.
and the moon is red.
Correct.
Okay, the reason it's red instead of just pitch black, it's in the shadow of the earth, so it should be pitch black.
Yes.
But light goes through the atmosphere, and this like this diagram here, light goes through the atmosphere into the shadow and lights up the moon with basically sunset colors, like red and yellow and orange and so on. But if you put volcanic dust there, it blocks the path of light going in, and then the moon may turn black. This one, the moon was black, it was invisible. There was a hole in the sky. There were, you know, like in a telescope, there was a moon-sized area with no stars, but you couldn't see the moon.
So the way you get data out of all these past history is basically looking at how bright was the moon during the eclipse?
Yeah,
Okay.
and you know, the darker the moon, the more volcanic dust. Yeah.
So even though the atmosphere is only attenuating by 30%, it's the path length of the atmosphere that just wiped it out and there's nothing to see.
Yeah, well, path length in the atmosphere is 40 times that, so 30% times 40 is.
Well,
But
23 to
yeah,
40.
yeah, anyway, it's a lot, yeah,
Fascinating. Thank you.
so.
Wait, and Rich, you're going to the next solar eclipse, where is that? Is that in your?
It's south of Tahiti,
Tahiti.
700 miles south of Tahiti,
And what's the date on that?
July 2nd.
Oh, right.
I'm leaving in
Coming
a
up.
couple of weeks.
Yeah.
So flying to Tahiti, catching a boat south from Tahiti, 700 miles due south.
Oh darn.
There's one island on the way.
Yeah. Are you stopping on that island?
Huh?
Are you stopping on that island?
Yeah,
Or it just keeps going? Okay, great. Yeah,
Yeah.
we'd love to hear a report on that one.
yeah.
You do that. Next
It's
week.
a smaller version of Easter Island. Easter Island is Rapa Nui,
Yeah.
which means big Rapa. This is Rapa Iti,
Yeah.
which means little Rapa. Yeah, named by the ancients, of which I'm not one.
No,
So,
we're all young.
okay.
Yeah.
If anyone wants a
Yeah, there you
card
go.
size of the image I have
Yeah,
in the back.
And he's got some other cards
Some other
there
cards
too.
too.
What, $5 each?
Yeah.
yeah, Dave showed me that and says, hey, I'd put that on the poster.
Yeah.
Spice it up a little.
Yeah. That's great. Good.
Thanks, Dave.
Thank you.
These are a few things I covered, some writings I do for Space.com or my own inside outer space thing, but one thing that struck me the last few days is some new imagery out of the Curiosity Mars rover. This is NASA's 1-ton rover, been there since August of 2012. It's driven about 13 miles since then. Kind of a slow-going thing, but it's tracking out the place. It's making some pretty good headway. These are just some images heading toward eventually. It's in Gale Crater. It's heading toward Mount Sharp at some point in the future. But this just was from yesterday. Kind of a shadow. There's Mount Sharp.
That's just like the first picture they ever took.
I know. Sand dunes. I mean,
There's a mountain in the background from underneath the rover, it's super cool.
yeah, I love that one. It's kind of nice. I go through these every morning. You can download Mars. It's so cool. And find out what the rover's doing. But anyway, a lot of tracks, a lot of making new imagery. They're about ready probably to attempt another drilling in some clay bearing units and do more analysis of that. So it's a pretty slow going effort, but it's robot, a lot of commands.
What is that thing? Was that a big sand dune in the back?
Yeah. One issue that we're having on another Mars lander, which is the NASA InSight Mars lander, which it has a seismometer deployed with a robot arm, and it also had this heat probe. Well, the heat probe got down a little ways into the surface, and somehow it's bollocksed up. So there's a big effort now to try to get this thing back in some operational mode. But this is a picture from this morning. But this is the seismometer, the white dome thing that apparently is working well. I don't know. Is there any rumors about this thing? I never hear any data, but
Well, they
I.
had the big, they had a release in late March, early April, that they saw the first Mars quake.
Yeah, the first Mars quake. So
It's, you know,
that's what they're
what
finding.
it's-
The thing on the left is the mole, which is trying to bury a probe into the Martian surface and understand more about the heat involved with the inner heat from Mars. So that they're working that issue, and it's been ongoing for months now, trying to fix this thing. But anyway, that's just another piece of Mars. Actually, here's the lander's leg. You know, this is built by Lockheed Martin, so just a local Colorado activity. Making tracks on the moon is sort of on the far side of the moon, not the dark side, but the far side of the moon, is China's Chang'e 4, and it landed there many, many months ago, but it's unleashed a rover called Yutu-2, and it's making tracks, doing its thing. There's a picture from the rover itself back at the lander, and again, this is a far side lander, never been done before. This is by China. Sort of a self-shadow picture that it took a few recently.
Are those round things like donuts it's doing out there?
Yeah. Yeah. It kind of turns around.
Crop circles.
This is sort of a, Barbara and I met the guy that did this map up in Canada here just a few days ago, actually. God, I can't believe we were up there. But anyway, he put this map together of where the Yutu-2 rover is sort of traversing around. And it goes to sleep sometimes, and then it goes to the 14-day, 14-night cycle on the far side of the moon, so it goes into hibernation mode. But it hasn't gone, you know, really a giant leaps for humankind yet, but it's making its way, and it's actually lasting longer than they hoped. So it's, you know,
The first one didn't make it through the night at all, right?
the first one has problems.
Yutu-1 didn't
Yeah.
make it through the
It
night.
didn't make it through the night, so it, you know, they vamped up this one, and so far it's working pretty well. There's not a lot of data yet coming out of this thing. It carries quite a number of international payloads, and the reports I get from a couple of the people on the international team is that they're getting great data. We're writing papers. We'll see the paper soon.
What's the distance scale on that?
50 meters per walk, it looks like.
Yeah. Yeah. 0 to 100 to 200 meters. As we speak, Japan has got the Hayabusa 2 asteroid probe, and this is an artist's concept of it actually impacting the surface of an asteroid with a projectile and sucking up the material that comes up from this. They're about ready. They did this operation and it was successful. And this relatively new picture from a few days ago shows this little white sphere down there, which is a laser guiding, you know, kind of an instrument that they use to lower the spacecraft toward the asteroid and to the exact target where they want to go, which is where they created this crater, artificial crater. And they're going to go down, coming out soon. I'm not sure exactly what the timing is now, but they want to go and pull some of that material out. And so then they're going to haul this stuff back to Earth. So it's pretty cool. Unbelievable mission. It's great to see these people pull these things off. This is a very complicated spacecraft mission, and you know, these are the kind of pictures when they're successful. They've been pretty successful. This mission has just done everything, almost everything they wanted it to do so far. Okay, big debate that just came out. As I was putting this thing together at 4 in the morning, you know, Trump's tweeting, "Why are we going back to the moon?" And so the NASA people are going crazy now. The point is that the president ordered them to go back to the moon. So now Trump has sort of thrown a wild card into the NASA mix, which is sort of predictable. I'm not quite as upset as some people, but the blogosphere is just full of all kinds of crazy messages to Trump about changing course here. And he wants to go to Mars. Why are we going to the moon? Well, he ordered NASA to go to the moon. So anyway, so we're going back to the moon. That's probably still the case. Pence is the chairman of the vice president.
That might be
What
close
is
to
he
the
chairman
truth.
of? He's not chairman of Trump, that's for sure. He's the vice president, I know that part. And he runs the National Space Council, which is actually a major body that's been recreated by the Trump administration to help guide NASA and the Space Force and all these other directives they're putting out. So pretty interesting, but the whole point is that Pence has made a statement here maybe a month or so ago about NASA returning humans to the moon in 5 years. And that was the mandate that Pence gave NASA. So, like I said, Trump's tweet yesterday or the day before, whatever it was, it's really thrown everybody into a kind of a turmoil. The eagle has landed. I love this picture. I just put it in here because I thought it was one of the best pictures I've seen on the internet. I couldn't believe this picture.
Photoshop.
Yeah,
Too good to be true.
yeah, I know. But one thing I reported on is there is a move in Congress about protecting the Apollo sites. If we do go back to the moon, the expectations of tourism and, rocket landings by different countries, do we need to protect, like we do down on here, kind of endangered architectural or archaeological places? And so there is a move that there's a bill in Congress that's sort of slow motion going through to help protect the Apollo 11 sites and several of the other sites. And the whole movement is sort of run by a group. There's numbers of people involved, but this one group in particular, For All Moonkind, has got ads. This is the ads they're putting out to try to get people to even think about protecting the sites. This is one of my favorite ones here. So this is moving through the Congress. We'll see where that goes. One thing about another piece of the action about moon, I'm kind of moon now because I wrote a book about the moon, but I'm following so many things. Robert Bigelow was an entrepreneur, hotel mogul in North Las Vegas, and he's just released some new images of some of the new designs for inflatable structures that he can put on the moon to create a early first moon base. And the thing about Bigelow you gotta watch, first of all, he's got a lot of money. Secondly, NASA's kind of intrigued by his ideas with these inflatable structures. NASA itself has invested in inflatable structures called TransHab, which is something that Bigelow grew from to create his designs. So we'll watch and see how this guy pulls this project together. But if you're going to go to the moon and set up shop and do it in an efficient, economical, and maybe a less costly way, these inflatable structures may be the way to go. He's actually got a demo inflatable structure on the International Space Station. He worked with NASA and actually provided a whole volume of one of these blow-up balloon kind of things. So anyway, one of the other things that caught my eye is there is a German company that actually is going to send, what did I write here? Where are my notes? Good, here we go. A laser system weighs roughly 7 pounds and can melt down local raw materials on the moon, moon dust particularly, and it's going to be launched, I think they were talking 2021 or something. They're going to go on a private lander and they're going to test this laser system to actually melt the lunar regolith, the top side of the moon. And it's the beginning of what some people envision as 3D printing. Can you create structure out of the lunar dust? And for astronauts that have been there, lunar dust is one of the big problems. And the moon is sort of the Disneyland of dust. It's got lots of caustic material on the top side that, kind of infect your spacesuit, can get in all kinds of equipment and bog things down. So this is a first test by this company to perhaps use a laser system to actually melt the lunar topside and perhaps make it less of a problem. Of course, artwork is cheap, but here's one of the big things that happened just as I was putting this together. NASA, they're trying to figure out what to do with this $100 billion space facility we have up there for the International Space Station. And they announced Friday, I think, that they're opening it up for tourists. If you have, okay, here's the kicker. There was more detail coming. Okay. Each year, 2 private astronauts will be able to stay on the International Space Station up to 30 days each, as long as they reimburse the agency's expenses of about $335,000 per day. The agency will also permit a private module to dock with the space station. So this is, for some people, this is a big deal. It is. It's a step in the right direction about potential hotels in low Earth orbit and habitats that are specifically designed for tourists.
They're talking about people who want to do science.
Yeah, and people that can do science up there. So they're going to offer this, and it's an interesting new overture by the government and NASA. So we'll see how this plays out. Unfortunately, the space station is getting kind of rickety. It's been up there for quite a while. So there is some concern about safety and, how much money it will cost to keep it in orbit. And meanwhile, China, I couldn't get on this because it just happened. China is going to announce a new set of science experiments that they're going to fly on their space station that's going to be put into orbit in the 2020s. And so that happens, I don't know if I wrote it down. I think it's on Wednesday they're going to announce experiments that will be, they've gone through and sifted through quite a number of experiments, and the Chinese are moving out on their space station. They see it like the International Space Station. It's a potential way to cooperate with other nations. Whether the U.S. is going to be able to participate in that, I don't know. But other countries for sure, Europe and also developing countries have been asked to take part in the Chinese space station.
Well, the name of their station is Heavenly Palace.
That's right.
Yeah.
Yeah.
This guy, I just put this in here because I thought this is the kind of experiment you don't want to do. Either in space or down here on Earth.
Huh?
I have no idea where this comes from.
That must have been after the second glass of wine.
Yeah, that was. I think that's it for me for now. We'll stay tuned on the guy with the mustache.
Brad, they have a continental breakfast that's free.
Thanks, man. We needed that.
Let's see if I can do this without referring to my notes here. Okay. Big news, April 10th of this year. This is the first ever image taken of a black hole in the middle of the galaxy M87. Almost. It's actually a picture of the gas and plasma around a black hole. The black hole is in this dark space in the middle where you can't really see anything, because that's kind of the thing with black holes. They don't emit any light, so you don't really see them. All you really see is the gas and dust that's around it. But it's actually kind of related to the orbits talk that I gave in March. Quick show of hands. How many people were here for that? Oh, that's pretty good. Okay. And so, since it was recent news and could kind of tie into the orbits talk, I thought I'd give a little talk about it. Now, if I really wanted to explain about black holes properly, I'd have to spend an entire lecture on special relativity and space-time and why things can't go faster than light. then I have to have another talk on general relativity and why that's the working of space-time and how that all works. But it turns out I can actually give an introduction to the idea of black holes using just classical physics, just the kind of stuff we used in the orbits talk, Newton's laws and stuff. And this is actually something I would like to have had at the tail end of that talk, but that talk was already plenty long enough. So at the end of it, I was talking about orbits and how things going in orbits around the sun, or Kepler's laws, elliptical orbits. And I mentioned at the very end that there are some orbits that don't loop back. These are hyperbolic orbits. The thing's going too fast to loop back. And I didn't really have a chance to say much about it. And that's what I really would like to have been able to talk about. And so what I want to talk about is the escape velocity. Now, when I'm talking about orbits here, I'm talking about coasting orbits, not under the thrust of a rocket or anything. And so the escape velocity is how fast you have to be going in order to never come back when you're coasting out. To properly do this, I really would want to talk more about something I actually talked about in my spectroscopy talk about 1.5 years ago, which is the difference between kinetic energy, the forms of mechanical energy, kinetic energy of motion, potential energy of position relative to a gravitational field, that sort of stuff. But as you can tell, I've been encouraged to make this short. So I'm going to blaze through this first part, and you can just focus on the end result here. Okay, so the kinetic energy an object has is 1/2 mv squared. M is the mass of the object, v is the velocity that it has. That's its energy of motion. Its energy for position relative to a planet or a star or something like that is minus big G, big M, little m over r. Now, big G is Newton's gravitational constant, which you saw in my orbits talk. Big M is the mass of the planet or star you're trying to escape from. Little m, again, the mass of the object we're talking about. And r is the radial distance you are from the center of that planet or star. Notice, this is always negative. So if you plot this going with respect to r, it gets less and less negative the farther out you go, approaching 0. If you want to escape, you have to have a total energy, that's the sum of these two, that's greater than 0. So you're going to add these two guys together, it has to be greater than 0. So if we consider the case where it's equal to 0, which means it barely has enough energy to escape, then you can set these two equal. Notice the minus sign's gone now, because this is on the other side of the equation, and you solve that for v. Do your high school algebra manipulation, there you go. That's the formula for the escape velocity from an object. Notice the little m's cancel out, that's kind of handy. So, here's the formula. QGM over R. There, again, Newton's gravitational constant, 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. M, the mass of the planet or star. R, the radial distance you are. And notice the little m is gone. That means this formula is going to work whether you're talking about a 1 kilogram CubeSat or 720 kilogram Voyager probe. They both have the same escape velocity. Okay, so it doesn't depend on little m, but it does depend on big M. And so what that means is the bigger the mass you're trying to escape from, the more velocity you need. You need a faster velocity to get away from it. That makes sense. You've got more gravity trying to hold you back. It's also dependent on the little r. And so because little r is in the denominator here, now the bigger r is, the farther out you are, the smaller the escape velocity is. And that kind of makes sense, because that basically says, if I'm trying to escape, the farther away I am already, the easier it will be to do that. So that's why the escape velocity is getting smaller the farther out you are. What does this have to do with black holes? Well, let's concentrate on this fact that the smaller r is, the faster the velocity is. But there's a problem when you're talking about planets and stars, and that is they have a surface. And so there's a minimum value of r, which is the surface. So there's nothing in the equation that limits how how small R can be, but there is that surface there. So, let's look at the surface of the sun. What do you need to escape from the surface of the sun? Never mind the fact that your rocket's going to melt. You start there. There's our equation. Value for G, that's the mass of the sun, the radius of the sun. You take those numbers, you plug them into that equation, you get out your calculator, you punch buttons, and you get 1,950,000 meters per second. About 4 million miles an hour to escape from the surface of the sun. Okay, now, that's limited by the surface of the sun, which is at that radius r. If we could put in a smaller r, we could get a higher velocity. So let's compress the sun down to a smaller size. So all I'm going to do is change r here to half size. Boom, our escape velocity is now up to 2.7 million meters per second. Okay, if you could compress the sun down even more, you could actually get that escape velocity up to 300 million meters per second. Well, that's 186,000 miles a second. That's the speed of light, which scientists like to call c. So what that would mean is light could barely escape if we could compress the sun down small enough that that was the escape velocity. If you get it any smaller, then the escape velocity will be bigger. See, I changed the equal sign to a greater than sign here. So now the escape velocity greater than the speed of light. And so now I'm going to borrow one fact out of special relativity, it's not classical physics, and that is nothing can go faster than the speed of light. So, light can't escape, it's black. Nothing else can escape. Anything that gets down that low, the R value that small, can't escape because it has to be able to go faster than the speed of light to do that. And so that means it's gone from the universe, anything that gets down there. So it's like a big hole in the universe, so it's a black hole. Okay, so then the question is, I've been talking about compressing the sun down. How small would the sun have to be for that to happen? So we take our escape velocity equation, and we just kind of invert it around. This tells you the escape velocity for a given radius. Square both sides, move things around. This now gives you the radius for a given escape velocity. And so now all I have to do is say, oh, well, what if I want that escape velocity to be the speed of light? Boink, plug c in there instead of v escape. And this is called the Schwarzschild radius. This is the radius at which an object with this mass would have an escape velocity of the speed of light. Okay? What is that for the sun? Plug in G, plug in those numbers, crank, crank, crank. It's 3 kilometers. So given that the sun's normal size is like 700 million kilometers, 700 million meters, getting it down to 3,000 meters is pretty tiny. That's crushing it down a good bit. Okay, so here's my picture of a black hole without stuff surrounding it. Okay, so you can't really see a lot there.
That's Photoshopped.
Fake stuff. By the way, that reminds me of something I had meant to mention with that first image. That image of M87 was taken with radio telescopes, not optical telescopes. That means the colors are fake. It's a pseudo-color image. That isn't what it really would look like if you were 55 million light years closer from here. Okay, but that doesn't look like anything. So let me mark where the center is, and oh, it's over here. And marking where the Schwarzschild radius is. Now, here's the significant part of that. Anything that happens at a radius less than the Schwarzschild radius, there's no way to get a signal out. Light can't escape out there. Any light signal, oh, there's my event, that's what's happening. Any light from it just gets turned right around to go down to the bottom because the gravity is so strong. So there's no way for me and my spacesuit out here to actually know that that event happened. And so this is called, the Schwarzschild radius is also called the event horizon. I can't see events that are below the event horizon because there's no way for that light or a radio signal or anything to get out of there and get to me. Okay, now this is all if I compressed the sun way down and I turned it into a black hole. But that was just so that I could get a small value for r. If my r values are big, like out at Earth, the equation is still the same. The escape velocity doesn't change, the orbital speed equation doesn't change, even if I have compressed the sun down to a black hole. So the point being, in case you were worried about this, if the sun turns into a black hole, we don't have to worry that all the planets are going to get sucked into the black hole. Their orbits don't change. They'll continue going around. We'll all freeze to death because the sun isn't shining. But at least we won't get sucked into the black hole. Okay, so that brings up the question, could the sun turn into a black hole? Could it get compressed down that tight? Relax. No mechanism that we know of can make that happen. So, the reason here is that the nuclear reactions going on in the sun heat the gas up. The gas pressure is holding things up against the gravitational tug. Even when the sun burns out and the nuclear reactions stop, and it shrinks down to a white dwarf, the actual material of the white dwarf can't get crushed, and that keeps it from getting down smaller. So our sun can't turn into a black hole. If I have a more massive star, then it is possible that when it gets down to the white dwarf stage, the gravity is so strong that the material itself can't resist the force of gravity. It gets crushed down below the Schwarzschild radius, and that turns into a black hole. Now, during the course of the life of a big star, it does a lot of things of shedding mass and that sort of stuff. But if when it gets to the final end stages, if the mass is more than about 3.2 times the mass of the sun, that will turn into a black hole. So that's the kind of mass we're talking about. That would normally mean that the original star was much more massive than that, because it would have shed mass off during its life. Okay, so how do we make black holes? You have a big massive star, it burns out, collapses down to a black hole. You got two medium stars, maybe they're in a binary pair, and they collide, and now that turns into one massive star, and it collapses down to a black hole when it burns out. If you have a star collide with an existing black hole, then what happens is the mass of that black hole goes up. What does that do? That increases the Schwarzschild radius from that equation. Bigger mass, larger Schwarzschild radius. And if that happens a lot, you get a lot of stars colliding with it, you get what are called supermassive black holes. And these are thought to be at the center of all the big galaxies. For instance, the center of the Milky Way has a black hole about 4.3 million times the mass of the sun. M87, whose picture I showed you at the beginning, that black hole is 6 billion times the mass of the sun. So, Schwarzschild radius for our sun was like 3 kilometers. For this guy, 120 astronomical units. So
What's an astronomical
that's
unit?
3 times the distance out to Pluto. That's a big black hole in the center of this thing. So, that's the basic idea, how you make black holes with classical physics. You take the potential energy and the kinetic energy, and you say, hey, that gives me an escape velocity. If I say the escape velocity depends on the radial distance and the mass. If the mass is big enough and r is small enough, the escape velocity is greater than the speed of light. Light can't escape, it's black. Nothing can go faster than the speed of light. We got that from special relativity, a talk I haven't given yet. And in that case, nothing can escape. And so it's like a hole in the universe. Now, there was one interesting thing, I think, about this. I used all just classical Newtonian physics to do this, and I came up with this is the formula for the Schwarzschild radius. If you do the full general relativity version of this, you can do a lot more work with a much messier equation. But 2gm over c squared is right in there. So that's the Schwarzschild radius. And that's actually how Schwarzschild came up with it. And so this is one case where the general relativity complexity actually gives you the same result as the simple classical physics. The messy general relativity also gives you all the weird stuff about singularities and time dilation and things I don't have time to go into. That'll be another talk sometime. So that's that. Any questions? All right, did I get it in on time? Okay.
When are you
Question?
gonna give your next talk on relativity?
Dr. Barr,
Actually, it's talk to me.
talk to John. Yeah.
I've taken over for this,
Yeah, I
for
can
this.
see doing two talks. One would be on special relativity and space-time and that sort of stuff. And once you got that, then we could do general relativity.
Let's plan those for the
And I'm not
winter.
gonna get nearly as equation. Special relativity is fun because the math is so simple. It's high school math, Pythagorean theorem, that sort of stuff. General relativity, I have a degree in math. I didn't get that stuff in my math degree. I had to go read general relativity stuff to learn it. So it's a totally different realm. But, you know, we can talk about it without doing the math, I think. Okay.
If you got the email that John sent out with mail.
Which the red
Jim
one?
Mayer, I think that you sent it out Friday morning, did you all? Or maybe you didn't see it. Okay, really, well, that's interesting. Well, are you on our email list? You just didn't look at our email?
Well, if it was one of the ones that we added, or that you sent me today, I haven't added.
Yeah, there was, no, I sent it out to you. Okay.
You guys doing good? Yeah. Not too thirsty? Not worn out after Dewey's awesome talk? My brain feels like it's gonna explode. So if you don't know me, my name's John Williams. I'm a NASA JPL Solar System Ambassador, and I work for the Education and Public Outreach Office of the National Solar Observatory. And I can affirm Dewey's recommendation: the sun's not going to turn into a black hole. It won't go supernova, but it will probably eat the Earth one day. Well, we won't be around.
Yeah, when is that?
4 billion years from now, just a
4
few,
billion?
it's give or take, way. The Earth is going to be uninhabitable by then. It'll be bad, or it'll be bad for us. All right, so so if you saw my picture that I sent in the, well, first we're going to talk about astronomy news. Come on, you guys wore this thing out.
Oh, battery running low.
That was part of the show.
Yeah, I got to plug in. Hold on.
Okay, did you do that?
Can anybody do a song and dance real quick?
Yeah, no, I've got a couple others. So the International Space Station, in case it's clear enough, will be passing over at 9:21. And, I think we'll be done here by that time, so hopefully, and we might be able to see Jupiter. It's rising about 8:22.
In the sunset.
But it's probably, within clouds too. And if it clears, Mr. Preston. Okay, space station. If it's very low, so if we see that at 9:21, it'll be over in this area. It's sort of west-southwest, or west-southwest and southwest. But there is a little clearing between the trees there, so you might see. And then you can decide if you want to go and spend the, what is it, 35,000 a night?
58,000 you get there.
Yeah, 50,000.
You have a coupon.
And just look that up. Also, Slash Day, unrelated to Skywatchers, but they're doing that at Blue Mountain on June 22nd and 23rd. And we always encourage people to get the slash, do the mitigation. We're getting into fire season here, so just wanted to mention.
If it doesn't stop raining, we're not going to.
Yeah, I hope.
We're not going to get to see the stars either. So I wasn't going to do astronomy news, but I got a wild hair late this afternoon. I was like, I got to do astronomy news. So we're going to go through that. I picked 6 things. That was really tough. But over Costa Rica in April, a washing machine sized piece of stuff from space came crashing down, and it broke up all over Costa Rica. What makes this different is that it's one of the chondritic meteors, which we think, one of the theories is that's where they have a lot of water and they're mostly kind of clay-like. And maybe, so astronomers have been wanting a piece of this thing. Now this went through the roof of a doghouse. That's what this thing is. So that's actual a piece of meteorite that hit the ground in Costa Rica. And so astronomers are going to try to get at that. Now they love these these are old pieces of information from the distant past. I mean, we're talking 4 billion years ago when the solar system formed out of the cloud. And so that's why they want to look at this so bad. Plus, hopefully it'll solve the, where all the water on Earth come from. Comets, meteorites, we don't have a lot of ideas. Bob's got lots of ideas, so keep it simple. Hello! Did I ever show you my picture of the moon?
That's yours?
I took this out of that telescope that Sam, I forgot, did I share this with you, Sam?
I think you did, you
Okay.
emailed it to me, yeah.
Well, the only thing is, I'm showing off, but there's, President Trump doesn't want to go back to the moon, but the moon is still providing lots of great information based on the seismometers that the Apollo astronauts left on the moon. And so, right in this area, there's a fracture. And so we think that the moon's still active. It's not active in the same way Earth is. There's plate tectonics going on in Earth, where the continents ride on the other basaltic material that's below. But on the moon, it's more like the strike slip faults on Earth, where things are moving like this, or actually where they're moving like this, based on, are caused by cooling. And so we're still, I just want to let you know, there was a paper that came out, and I thought it was interesting based on the information we got on Friday that we're going to the moon. No, we're not going to the moon. The moon's still providing good stuff. If you came a few months ago, Alan Stern gave this amazing talk about Ultima Thule, or no, it was Carolyn did that. He did New Horizons, but New Horizons flew past this thing. And, we have a scat of satellites, probes now, looking at these objects they're not, if you look at the moon, you see all the craters from the great bombardment that happened way in the past. Mercury shows it, Venus shows it. The only reason Earth doesn't show this damage from this time period is we have weather. And so it erases all that evidence of what our violent past. But Ultima Thule and these other objects out in the outer solar system, they have a much more peaceful environment. And there's some papers coming out now based on all the data that we're getting back from New Horizons slowly because it's so far away and it just trickles the data back to us. This is two objects that just kind of came together. And not a lot of, there's some big craters, mostly that surface looks pretty smooth. So we know that it doesn't have the violent past that the moon and the other bodies of the solar system had. Kind of an interesting, just watch for these papers. There are going to be hundreds of them coming out in the next year or two. This looks kind of weird, and this is more physics related, but this is the classic double slit experiment was in general relativity, or it means not in quantum physics. Light acts not just like a particle, but it acts like a wave. And so when you put it through these twin slits, it actually creates these wave-like patterns. And it turns out that antimatter acts exactly like regular matter. Now, they have never been able to measure this. And the way they're able to do it is that antimatter, we have a universe full of regular matter. And when a particle of antimatter, the exact one, encounters its twin in the normal universe, it gives off, it just destroys itself, annihilates everything. So what they've done is take positrons, which are the antimatter equivalent of an electron, and run them through this experiment, and we can create these in small amounts now. And they found this out. I think this has some interesting implications for physics on down the line, so I threw it in here because I thought it was pretty interesting.
How do they get the positrons to go through a slit without annihilating themselves?
They keep them in that magnetic container, the field, so that they don't encounter their electron counterparts. So they're being isolated in the, I'm sorry, go ahead.
I was gonna say like Star Trek is.
Yeah, that's how it worked. Antimatter containment.
Magnetic.
Is that? We're all a bunch of geeks. This is the weirdest headline I've seen in a month. Could a supernova have made humans by, stand up and look around? Now, this comes from, this comes from a guy at the University of Kansas. And so, because I'm from Kansas, I know it's right. But he had this, there's been some theories lately that supernovas, over the past about 6 to 7 million, 8 million years ago, there was a lot of fires on Earth, wildfires. So if you think the wildfire seasons have been bad, they predicted back 7 million years ago, all over the Earth, they were super bad. And one of the ideas was that there were some supernovas, and as these cosmic particles come down into your atmosphere, they cause lightning. And so, I'm just saying this is what the paper said. I said weird, I didn't say true.
I said it's supernova because they stood up and looked at it, that might be that was cosmic rays.
So well, this is one of the reasons for the forest fires. And what happened on Earth during that time is it took a fairly dense forest and created more savannas, more plain-like things, which required us to stand up, look around, check out the supernova, and the saber-tooth tiger that's coming after us, or whatever was the predator back then. So, yeah. I thought it was
Put in the
cool.
magic
Rays
mushroom.
and pollen.
I
Against nature.
What? I can't remember. I'll send it.
Yeah, I'd like to check it out.
Does anybody know what this is?
Cosmic background.
It's the cosmic background radiation. This is the echo, the Big Bang. This is taken from the Planck telescope, which is up in orbit. And, one of the weird things that Planck has shown is that what we know about the universe is probably all wrong. And so it's just one of those things. But what it was really, one of the weird things that it showed was that there's a cold half to the universe and a hot half to the universe, except for this hole of cold down here in the hot half. What the heck, so that doesn't really, I have to look at my notes because this is really complicated to me. But I think it's pretty good that I remembered all that.
It's not the Milky Way that's all red.
Apparently not, it's the hot, that part of the universe, they said they took it out, because I was wondering the same thing. So they compared this to the most advanced maps that Planck had ever produced. Now we're getting to the edge. Planck isn't taking data anymore. So now this is going to be the most detailed, well, not this map, but the one they produced for the paper in astronomy, astrophysics. I wrote that down. That they only found the spots appear, but they're not statistically significant. So they do not know why that hole sits there like that. And so it really leaves two possibilities. One, that the anomalies are just flukes of statistics, that it's just noise. It's just random stuff. But the second one is that there may be some kind of physics that isn't currently explained by the standard model of how the universe formed. This is the one they're kind of leaning towards. And I think they didn't say it in the paper, but I kind of wondered if they're trying to merge in dark matter stuff with it as something new that we just don't understand yet. I threw it in here because that's the way the universe is. It's just continually wows us, right? So we're going to move on to, if you saw that picture, any questions about any of that stuff? Any of the astronomy news that I had?
Yeah.
No? Ah, I did that good. That's awesome. Yes, sir.
Was the dog home at the time?
The dog was in the doghouse and did not get hit. Which is better than the dog that was killed on a dock in like 1811 by a piece of Mars in Egypt. Only dogs that have been killed by a meteorite. That dog worked out.
I guess no humans have been killed by meteorites. Somebody got bumped on the head when it came through their house, but that was the only thing. Amazing to me. Well, we're gonna talk about meteors, so this kind of rolls right into it. If you saw, weird. First I had to show this. She wanted me to show this off. If you guys were around the other night with the thunderstorm, this is a view from my house. And I actually caught this sucker. Yes.
That was 2 nights ago?
Thursday night.
Thursday night?
So-
Or so?
It was about 9 o'clock when I took this picture. I tried to get out there. Lightning was hitting down on, this is Scartop, right here. 120th Street, this is McCaslin 36.
And you're taking that from Shimmery?
Yeah, we live at the top of Shimmer.
Yeah.
So why these blank screens? I wonder if so we went out to western Kansas a couple weeks ago just to, I've always wanted to go out there and take Milky Way shots of Mount Sunflower. Now, Mount Sunflower is the highest point in Kansas. Been out there many times, but it's no mountain. You can throw a stone. Colorado is where Sam is. So, I mean, it's just right there. It's like a little rise. There may be some dirt. But, so we went out and took some pictures. And, yeah, exactly. And the wildflowers going crazy. I take a lot of pictures, but we ended up in Wallace, where there's funky bison art. I don't know what that was made of, but it was huge and it was metally, little rings. There's this 36-star flag from 1870s. There's my wife in the stagecoach. So that was on the Butterfield Overland stage. There was also, before Wallace was at Wallace is where a fort used to be to protect railroad workers, surveyors, and the stagecoach from Native Americans who thought we were stealing their land, which we were. So, so we were hanging out with Buffalo Bill Wild Hickok. Wild Bill Hickok, who was looking pretty bummed out, even though my beautiful wife is standing there right next to him. But he's forlorn because he got back from I didn't know this story, he got back from a patrol and his wife, who was there at the fort, left. And he totally was like, didn't know where she went, he followed her out. So I have to imagine that he's bummed out because she's taken off. What's that?
Buffalo Bill's a different guy.
Buffalo Bill.
Buffalo Bill's Bill Cody, that's Bill Hickok.
Oh, you're
That's
right.
Bill Hickok, the guy.
You're right. I'm sorry. I've confused me. Thanks. That's why I've been on you. Everything else I'm saying is wrong. Kansas is full of big, ugly monsters. Dragons.
What is that?
I can't remember the name of this thing, but it was,
Is it land or marine?
it's a marine. It's that thing. So in the surgeon found all these stories. Now, I'm building up to my story, so please bear with me. This thing was it's like 40 feet long. I mean, it was as long, I didn't take a picture of the whole thing because I couldn't get it in the camera, but it's as long as this. They found it kind of half exposed out there in the 1870s. And this is a cast of it. The real one is in Philadelphia. Because the surgeon at the fort was like, I don't know what this thing is. And he sent a part of it out to paleontologists in Philadelphia. And he's like, can you send that all to me? And so they packed it all up. The funny story is that the guy who originally, I can't remember his name, the guy in Philadelphia originally put the head on the tail of this thing. Because all the animals on Earth now have long tails or long necks and short tails. And this one has a short neck and a long tail. So, anyway. I got licked by a bear. That's a fake bear. And I didn't know, but there are this geodes and meteorites and fool's gold in Kansas. So I thought that was kind of cool. But really, I was going out there for Mount Sunflower. And it's 4,039 feet, so it's really tall. Mount Everest, I mean, I can barely breathe. And those aren't meteors, those are planes and stuff crossing the sky. Looking north, a lot of light pollution, even though it's in the middle of Kansas, there's farms everywhere. What's that?
How many seconds are you exposed?
Oh, the exposures on this were about 30 seconds at ISO 12,000. And so it's with a 14mm lens. This is bright old Jupiter. Looking, that's the Milky Way just rose. It was about 11 o'clock. And those lines, these kind of streaks in the sky, are cirrus clouds. They're up there high. So this was a panorama shot of about 180 degrees, about 10 frames that I put together. This plane is moving straight down it just because of the curve of the lens. It looks like it's curving. Jupiter again, right old Jupiter. And Mount Sunflower. So you can tell it's high.
Are the lights farms, or you got some small towns out there?
Well, you know what's interesting is that, I go back to this one. So this was a farmhouse about a mile away, and the fog was as thick as anything I've seen up here. And this is in the Smoky Hill River Valley. Although the river, Smoky Hill River, eventually joins the Republican River to form the Kansas River in Junction City, Kansas. And so the Smoky Hill River starts way out here in Colorado. They call it the Smoky Hill because of this fog that forms at night. And I've never ever experienced that. I haven't driven out there very much. I've been out there many times, but that's why I was always wondering why they call it the Smoky Hill River down there. So kind of cool, close up of Mount Sunflower. More planes. That was the busiest doggone plane night. This is one of the few pictures that doesn't have a plane or satellite wandering through it. Another plane over here, the blinking lights. At about 10 or about 11:15, I'm sitting there taking that big panorama that I told you about, and I see this thing. I have seen many things in the sky, but it was about a fist big. And it wasn't, so that's not a shooting star, that's actually what I saw. It was about magnitude 4, so it wasn't super bright. It was silver and shimmery, and it just crossed the sky, like this.
-4?
4.
-4?
No.
Well, why did it show up so well then? It was
30-second exposure.
No.
Plus I brightened it up a lot.
4th magnitude won't show up too much though.
Well, okay, then it wasn't as bright as Jupiter. It was pretty dim. I mean, I'm telling, I brightened this up quite a bit, so I'm gonna be honest, I photoshopped this. Brightened it up, the colors are brought out. The colors were there, it's just brought out. But anyway, so this thing crossed the sky, and finally I go, crap, I have a camera! So I turned it, I forgot to put my movie in. Anyway, I got it set.
Do you give a direction?
This is, well, it started in the west, and this is looking east now. And so it just came here, and just kept going, and it's...
Like a satellite, it would be a direction would be fine.
Exactly.
But it was a long line.
But it was a long...
It wasn't a moving dot.
And so I was like, is it outgassing? Like a rocket that went up and it was outgas, like gas came out?
Those 60 they just sent?
Well, that's eventually what I figured out. I emailed Leonard the next day and said, wow, I saw the weirdest thing, what do you think? And he's like, don't know, but what do they call it? Starlink is causing some issues. Now I'd forgotten that it launched the day before. This was Friday 2 weeks ago. I will.
Oh, okay.
I will.
Okay, sorry.
There, yeah, more pictures. So I saw some pretty crazy things. Wow. These are way out of order.
I don't understand, did you tell us what it was or not?
It was Starlink.
What's Starlink?
So I'm gonna get to it. Starlink was launched by SpaceX on Thursday, May 29th.
Oh, it's all the ones in a row.
60.
60 satellites in a row. So what was it? It turned, or the WHO, SpaceX, and there's their logo. They launched on a Falcon 9 on Thursday, the night before I was out in Kansas. I didn't even think about it. But I wanted to talk about it because it presents this interesting dilemma now in the astronomical world. This is going to be eventually a mega constellation of satellites. We'll get into the numbers here in a minute. But SpaceX is not the only one working on this. We've got OneWeb, Amazon Telesat. are working on other similar mega constellations. And the what? It was launched May 23rd, I'm sorry, the date wrong. From Cape Canaveral. They launched 60 satellites just like this. They were all queued up and released. Their solar panels came out, and they moved in a, they were launched aboard Falcon 9, and they move all together for now. These things weigh about 450 pounds a pop. They orbit between 341 and some will go up to about 500. Their constellation will be multi-depth. The ISS, just for comparison, orbits about 254 miles. So, the why? These things are designed to bring the internet to the world, to places that don't have internet like us. Oh, we do. Anyway. But Africa, South America, Antarctica, places like that, places that don't have normal internet service. It'll take 6 more launches of 60 satellites each to create basic coverage. They're flying 12,000 satellites to do an entire, this is a mega constellation. Eventually. They haven't given a time frame. Can you hit the space bar, please? Space bar?
Oh, yeah, yeah. Oh, space.
Come on.
Okay.
Yeah.
Can
No. No, it's not gonna play. Dang it. So this guy took a,
I didn't do anything.
I did.
Oh, okay.
This guy did a movie of them all, they were in a row. I couldn't see the individual satellites. I didn't have my binoculars with me.
This is the guy in
Myers.
Holland? This is the guy in Holland?
Yeah, the guy in Holland. So he took this movie and it's these 60 lights. He counted 54. There were 60 that were launched. Anyway, so what does this really mean? Earth orbit's pretty packed. But this all started with the launch of Sputnik 1 in 1957. Since then, just 8,100 satellites have been launched into space. 4,900 remain in orbit. Only 1,900 are operational. 500 of these are in low Earth orbit. 50 in these medium orbits at 20,000 kilometers, and 1,350 are out in geostationary orbit. This is according to NASA and some other places I found on the web. Geostationary orbits at 36,000 kilometers. So remember, these are low Earth orbit things. The pros, you know, it's going to bring internet to the world, so that's kind of cool. They're designed right now for 95% disintegration when they re-enter. Well, they're designed to be able to be deorbited if they go back. So a lot of the satellite makers now sign agreements with all the superpowers with the UN to be able to deorbit these, because we don't want a bunch of junk in space, right? They're designed to avoid other satellites by using ion thrusters, and that's how they're going to move from this line of 60. Right now, when I saw it, you know, it was 10 degrees of 10 degrees of sky. And now the leading satellite is about 2 hours ahead of the trailing satellite. So they've started to spread them out. And they do that with these ion thrusters. Ion thrusters use little electrons just to, there's not propellant, but they're propellant, but it's totally doesn't have any byproducts to it. But it's very slow. So they just slow thrusters moving. They're not like the TIE fighters and Star Wars. The cons, all the astronomical places are coming out against it this week. AURA, which is the umbrella of the company, or the NSO, AURA is the Astronomy University Research Association, and they run NSO, the LSST, Gemini Observatory in Hawaii and Chile.
NSO, National Solar Observatory.
Thank you.
Right, yeah.
And we call it.
Where you work.
Wherever. So I have to make that disclaimer. This is my fault. They're against it, and because we have a telescope down in Chile that we're building called the Large Synoptic Survey Telescope, which will take these huge images of the sky every night, produce gigabytes of images, and what they're looking for are changes like supernovas, novas, meteors that might hit Earth, any changes in the sky. So it's a synoptic program to take in the whole sky at once. And there's, of course, where Aura thinks that this is going to be bad for LSSTs. It turns out that there's some other reasons, but it won't affect LSST so much because only 0.1% of the telescope's pixels because of the way they do it. Yes, sir?
So take 100 by 100 piece of your image, which is tiny.
Yeah.
There'll be a satellite in
That's what they're thinking.
there. Take another 100, there'll be one in that. So that's a huge number.
This is a huge. They were making it sound like it wasn't so big. But it's good to know. So, but for telescopes like the Gemini, who have longer exposures, they're thinking it might look like that. And those are galaxies back there. It'll destroy the night seeing that we have on Earth. This is a Photoshop image. I didn't do it. But you know, the Earth is, this is what lower orbit looks like. That's what geostationary orbit looks like, and we're gonna have 12,000 of this. I'm not suggesting that we not do it, but the IAU, the International Astronomical Union, came out against it as well. And they think that we need to, SpaceX, Amazon, these other companies, need to work with the astronomy community instead of just launching a constellation. They're saying, hey, let's work together and create something that we can, that's sustainable.
Well, what does it mean?
What does it mean?
I mean, what is suggested?
For
If
the
you want
IAU?
bandwidth, this is what they're gonna do. Right? I mean, and it's very, I think the good news is that only one company's gonna win. Everybody else is gonna, somebody's gonna put 12,000 satellites up, everybody else is gonna lose.
Well, you know,
But you're still down 12,000 satellites.
we were talking about that. This really is almost like a land grab for satellite, for orbit, right? Well, and also this week, this was an interesting thing that happened this week. The conversation turned to, the rich countries that are able to afford observatories are getting all bent at the expense of the people who don't have the same privilege that we have here in the United States. And that's been an interesting have-not discussion that's been going on. I brought this up only because I want to show off my pictures, but I thought it was so damn strange that this, out of all the things that I get to see at night, and I see this line of stuff. I wish I'd had my binoculars to check that out. Yes.
Supposedly, when the full constellation is working, SpaceX is gonna generate $30 billion in revenue in 1 year.
I didn't even mention that.
And what are they gonna do with that? Go to Mars.
The reason Amazon and OneWeb and Telstar are looking at the same thing is because this becomes a huge moneymaker for all of them to provide this internet service. And not just for places in Africa, but for, right now there's a huge latency with like HughesSat and these things. Being in lower Earth orbit, having a wider constellation, they're hoping that latency goes down and they'll be able to do more. Anyway.
But how much will that cost? Like, will it be more than mountain broadband?
SpaceX hasn't been talking about how much any of this costs.
Is it just for the rich?
Do they know their time frame of launching all of
They
this?
haven't shared that either. But it's going to be within, they said maybe in the next year they'll launch those other 5 rockets, or 5 groups of satellites. And that'll give the basic coverage and then the rest of it. I just was,
But these are SpaceX's satellites, launching the SpaceX rocket.
they're launching the
So they're not under any jurisdiction or are they? In other words, they can't be stopped.
They can't be stopped.
Unless approval.
Who did they have to get permission from?
Well, just like every other rocket that gets launched by NASA goes through FAA approval.
And FCC.
And FCC and all this.
But they don't necessarily approve each satellite, it's just the launch.
No, the only agreements they have on the satellites themselves are they're able to be deorbited when they become non-functional. And so,
Who governs that area anyway out there?
Wild West. I mean, other than the people who I mean, the government could say, no, we're not gonna let you launch that rocket. And then they would just go down to Guyana or over to Europe and launch it. Hey, I don't know, I'm just saying, these
At what point do you have so much junk up there, that you have to fight your way out to get through to Mars?
well, eventually, I think what the big worry is that if we want to send tourists up there, like what Leonard suggested, is that heaven forbid a tourist gets killed on the space station.
Yeah.
Or heaven forbid one of our astronauts gets killed going to the moon or going to Mars later. Because we've put so much stuff in orbit. The stuff out in geosynchronous orbit, we can't, that stuff doesn't get deorbited. It just sits out there. And it does look pretty crowded, but space is big, but, you know, that's not a very good excuse given the constraint on resources that we have.
So, John, on this, and if you don't know, I totally understand, but, so all the red and yellow things, what are those compared to the little blue things?
So the colors on this from, I'm sorry, I didn't give a reference or anything. And I can't tell you who this is from. The colors mean different kinds of satellites. Some are communication satellites, some are Earth orbiting satellites, some are, or I mean Earth observation satellites. Some are military satellites. The colors mean those, and I don't know which ones are what. I didn't break it down by time, so sorry about that.
That's
Something to think about. Anyway, I thought this was good.
Great.
If you guys have any more questions for Dewey or Leonard, feel free to grab us and
suggested, John, that you might do, before we wrap up here, is take a look at our website and a quick walkthrough.
you guys interested in that?
Yeah, just so, and then you'll know where to go to get this sky charts for still pictures. You want anything more? The internet seems to be working fine.
Not good, there goes the photo.
And then after this, we'll do a group photo, maybe even put one of those great pictures.
Well, that one.
That'd be cool.
Yeah.
So to get to our website, it's skywatchers.co. CO doesn't mean Colorado. It actually is Columbia. Just like .com. But, you know, it was short, Skywatchers was taken, .com was taken. I bought this one. Oh, you got this one. Here, you can see mine.
What was it again?
Sky-watchers.co.
Okay.
And so, what, you know, this is not left justified, because I did it, and I still don't know how to do that. John, you're gonna have to teach me.
Well,
So
and
that's
you'll notice
our-
it's out of date because I haven't updated.
Yeah, and then you're gonna update.
So what we have in the middle is the next meeting information.
This is what you first see when you go to the website.
And then we also have upcoming sky events, which I need to be better about getting up quicker into their day. Sorry about that. There's some few more things down here. We have our Facebook page, which Carolyn Collins Peterson, she manages for us. And she actually keeps it very up to date with pictures, like we put up the picture of the group today from the last meeting. We haven't done that yet. And then right here is the sky charts. On the home page you can find. The reason it's moving up and down is I have a little dynamic thing going. It's spacing out the announcement at the top. I know it's a little annoying, but if you want the sky chart, right now the May sky map is up. And it's just a PDF that we print out and hand out to you, but if you ever want it, the new one will be up. I usually put it up by the 1st. I apologize. This week was pretty nuts. So I'll get it up tomorrow probably.
And then also they can go to the very top there where it says sky charts.
Right. So you can click up here and go.
Directly there.
In here, I have the weather for today, and the sunrise, sunset. This all pulls from, it's dynamic, so it pulled in.
And then you added the scope voucher, because we haven't gotten anyone asking for that, right?
No,
I like this idea of scope boundaries on visits. If you've got a telescope and you need somebody to come and help you set it up and, help you use it. We have people, Sam's volunteered before.
I would volunteer though.
Yeah, we've got a number of people who do come and help. So, but you can just let us know, email us or whatever you do. This is the time of the year that, you want to do that.
U.S. Naval Observatory has got their thing working again. This is tonight's lunar phase. And we just put a little ballast in this little thing, the weather. If we blog here, and also Carolyn's, mine's not on here, sorry.
Yeah.
But mine's kind of.
Yeah, well,
If you ever, I put in some other information here too, like if you can report a fireball, and you go onto a map and you can input where you saw it, what direction you saw it, how long it was, how bright you thought it was, what time, the color, and all that.
that's really important.
And what they do is they put it together with a lot of other observations. They say people have gone, seen fireballs over Michigan, and they triangulate it, and they'll find meteorites in the snow. They'll send people. There are people that go out using the information to find these meteorites. If you see UFO, let us know. I need to report my. I should have reported. Actually, a lot of people were reporting the next day. And then if you want to do citizen science, I put in a bunch of sites, and the coolest one is Zooniverse, and that's where you can go and help them catalog images from Hubble had a group of images, and they'll have you go in and you can classify them. You don't need any special training. All of it's done online, and it's a cool way to be involved in real science. This is all on my website and under the links. And of course, there's if there's any other announcements in these places, I want to do a lot more of this page. I just haven't yet. If you have suggestions, let me know. You can send. Well, if you send any email to Skywatchers, we'll get it. I have a catch-all account, so I'll at least see it. So jerk@skywatchers, sky-watchers.co will get to me. Hey, Williams, that'll get to me. The sky charts are under this link. Again, I have some other information, like what kind of stuff is in that star chart, how I create it. I probably got iridium flares on this. I use Heavens Above a lot for some of the information. But if you're interested in what is going over in the night sky, heavens-above.com is a great place to get that information. It actually has the Starlink leading satellite times and the trailing satellite times of that train, which is kind of cool that you can go out and see it. Now, know that a lot of the Starlink, it'll say what they are, what the magnitude is, and the magnitude is the brightness of the object, and it goes from, like right now, Jupiter, is -1 magnitude?
2.5.
2.5. And we're getting close to, yes sir?
Opposition.
We're getting close to opposition, which means Jupiter is super bright. Oh, one thing we didn't tell you is that if you get to go out and see Jupiter, because it's getting so close, you should be able to see the moons, the 4 big Galilean moons, the 4 largest moons of Jupiter, in binoculars. You don't need any special.
Pretty much anytime you
John, isn't the red spot going away?
I didn't include that, I should have. Yeah, the Great Red Spot, lately there's been some movies of it sort of unraveling. It's been getting smaller and smaller, and the red stain of that storm is starting to push out into the into the cloud bands of the planet. What's interesting about this is the Galilean, this red spot was noticed by Galileo back in the 1600s. So this storm has been going on for at least that long. And perhaps longer, we don't know. We didn't have telescopes to look at Jupiter. But what Dave is talking about is a real thing that they've been studying. That'll be in some of the news, like Space.com had stories about astronomy, sky and telescopes all over it. Those are astronomy.com, sky and telescope, skytelescope.com. We'll have
And
it.
then click on the Skywatcher's gifts.
All right, for the most, we need to get Leonard's book in.
Yeah.
So, a few of us actually produce stuff, Leonard being probably the most, I don't know, Mark is the most prodigious.
Yeah,
Or-
well, yeah.
So, hold it, we're trying to get started. Anyway,
And
so you can buy online
or from
Leonard's
us.
books, or from us.
Yeah.
You'll pay the price what Amazon, whatever Amazon's paying or charging for Leonard's book today, which changes a lot, like cents a day. So the number I got there is probably wrong. But you can go on here and you can order it through Amazon and pay for it. We don't get, well, I do because I have it come straight to me, but like my Hubble Star cards are there. Mark Peterson's music, space music, that's there.
And it's wonderful. I've got 6 of his CDs. I haven't told you about this before, but I've listened to them probably about 300 or 400 times.
It's how she stays so chill.
And it's just beautiful music. It's great. And then Astronomy 101 is Carolyn's book. And then we got Leonard's Mars book. We put the moon up there too. Carolyn's space exploration book too. And but if you want them, talk to us at a meeting because we'll, at least Leonard and I will give it to you at our author's cost, in shipping.
And I charge $15, that's the Canyon rate for the star cards. I haven't put up the pictures that I've got, but they're normally 25.
And
If you're buying from
we
them.
have them back there, if you want to see.
I've got them back there. You can buy them if you want. Go down to Boulder Bookstore,
They have.
Into the Wind,
and-
Denver Museum of
No,
Nature
and the
Science.
Wonderview Cafe gift shop.
Oh, that's
And
great.
they're very supportive of local artists too, and they carry the books too. They have a special deal if you buy Leonard's Moon Rush book. They'll give you a bottle of Budweiser beer that's been special for the Apollo 11 moon landing, with the eagle on it. We put that in touch with, I'm sorry it's Budweiser, but it's a special beer, it's like red, it's like a, I don't know.
Anyway,
But yeah, so we wanted to kind of give you, we do want to update it, but, I said to John, if you got a little time, why don't you walk people through this? Let us know if there's anything else you want there, or you want to put up on the website.
and I have to say, I've been very bad. I try to put up the links that we have. I have to apologize, because I feel bad. But if you want to see stuff like that, I need to put Dewey's, the PDF of your paper for the orbital stuff that we have.
But you want that on there?
Alright.
And then, you've been videoing these presentations, and someday, those, I don't know if the link will be on there.
I need to put, for the past year and a half, it's been a while, I've been videotaping them for, remind me, in the back, your name, Daxie? Dacry. I thought so, but I wasn't sure. But usually her daughter comes, but tonight she's not able to. So for people like that, if you're miss one, you want to see it, these take a lot of time to put together. And I just need to take the time, put them together, put them up on YouTube, link them in here. Eventually it'll get done. I promise.
Barbara, you might tell other people why Carolyn isn't here.
What, Carolyn? What?
You might tell other people why
Why
Carolyn
Carolyn
is not here.
Because she's writing another book on observatories. And when did she say it will be published? In the fall, I think. So we'll have her give a talk on observatories around the world. under deadline. I think she's got a week to finish it or something. So,
Leonard, do you know how that feels?
yeah,
I think she said that last week, she only had a week.
yeah, she did.
All right, you ready for the
Yeah.
photo?
So let's do our group photo and then we'll see, it's 9 o'clock right now, so about 21 after, might do it.
Did you have anything to do with
The second one, I held on a little week. Some questions. They were. Saw it, that's documents. Yes, I don't know if there's going to
Yeah. I don't know how
well, we gotta put the big ticket in. I don't know what's going on.
we have a better chance. We can see it. Yeah, like I
God, I got to know the best. Just killed right off the first part of it. But he did my son. Right, for the sign.
So that your sign will go around the